Good morning. Am I audible? Good morning.
Yes, sir.
Okay, fine. So we'll start. My screen is visible? Screen is visible to you?
Yes, sir.
Okay. So we'll start this Y parameter. Let me connect my board. Okay. We'll start Y parameter. In the last class, we have discussed Z parameter. So Y parameter, it is known as short circuit admittance parameter. Okay, it is basically Y means admittance. Okay. Now, how this Y parameter it is calculated in two-port network, we'll basically understand the theory. So, Y parameter of a two-port network may be defined by expressing the two-port current I1 and I2 in terms of the two-port voltages V1 and V2. So, in this case, basically, the input current and output current, it is expressed in terms of input voltage and output voltage. So, the basic equation for this Y parameter, it is I1 equal to Y11 V1 plus Y12 V2 and I2 equal to Y21 V1 plus Y22 V2. This is the governing equation for the Y parameter. Okay. So in Z parameter, if you can remember, in Z parameter, we have expressed the input voltage and output voltage in terms of input current and output current. So V1 and V2 was expressed in terms of I1 and I2. But in case of Y parameter, the I1 and I2, it is expressed in terms of V1 and V2. So how to calculate this parameter? So first of all, we need to express this equation in terms of matrix form. So in matrix form, this will be I1, I2, and then it is, so I will share this thing in board. Okay. So my board is visible to you, na? Board is visible? Hello, board is visible, na?
Yes, sir.
Yes, sir.
Okay. So basic equation for this Y parameter, it is I1 equal to Y11 V1 plus Y12 V2 and I2 equal to Y21 V1 Y21 V1 plus Y22 V2. So if we want to write this thing in matrix form, so this will be I1, I2, and then your Y matrix parameter will be Y11, Y12, Y21, Y22, and then this will be your V1 and V2. This is V1 and V2. Okay. Now we need to calculate this parameter. Okay. Y11, Y12, Y21, and Y2. So how to calculate? So first of all, if we make this V2 equal to 0, V2 equal to 0 means output is short circuited. Output is short circuited. So if V2 equal to 0, so we can calculate Y11. So Y11 equal to I1 by V1 and then Y21 equal to I2 by V1. Is it clear? Any doubt? Similarly, V1 equal to 0, that is input side, it is input is short circuited. So that means your V1 equal to 0 means your Y12, this will be equal to I1 by V2, and this one, this parameter is 0. So Y22, this will be equal to your I2 by V2. Any doubt from anyone? Is it clear how to calculate this parameter? Any doubt? Any doubt from anyone for this derivation? Are you there? Hello? Hello?
Yes, sir.
It's okay? Is it any doubt?
Yes, sir.
Any
No,
doubt?
no, sir.
Okay, fine. So okay. So the individual Y parameter for a given network can be defined by setting each of the port voltages equal to 0. So whatever we have done just now. So when the output port is short circuited, that is V2 equal to 0, Y11 equal to I1 by V1, where V2 equal to 0. Now this Y11, it is known as basically driving point admittance. That means at the same port. That means when we are considering this input, so at the same port, we are calculating I by V ratio. Okay, so that's why it is known as the driving point. These are the same point, driving point. This is known as the driving point admittance with output port short circuited. It is also called the short circuit input admittance. It is also known as the short circuit input admittance. Similarly, Y21 equal to I2 by V1, where V2 equal to 0. So this thing we have derived. So Y21, it is basically you are measuring the current at the output port and your input is at the input side. There is an input voltage. So you are going from 1 to 2. So 1 to 2 you are going. So in the forward way you are going 1 to 2. So that's why Y21, it is known as the transfer admittance with output port short circuited, and it is also known as the short circuit forward transfer admittance. So this is known as the short circuit forward transfer admittance. So you are going in the forward direction. That's why it is forward transfer admittance. Next, another case when the input is short circuited, that is V1 equal to 0, Y12 equal to I1 by V2, where V1 equal to 0. So Y12 here you see you are going from 2 to 1. So it is kind of reverse. You are going from output to input. So it is a reverse. So it is a short circuit reverse transfer admittance. So Y12, it is the transfer admittance with input port short circuited, because V1 equal to 0 means input port is short circuited, and it is also called the short circuit reverse transfer admittance. Now next is the Y22. This is I2 by V2, where V1 equal to 0. So Y22 is the short circuit driving point admittance. So here you see at the output port, you are giving the input voltage, and output port you are measuring the current. So that means at the same port you are measuring the admittance. So that's why it is known as the driving point, short circuit driving point admittance with input port short circuited. V1 is 0. So input port is short circuited, and it is also called the short circuit output admittance. So these are the basically how we can calculate this Y parameter. So I think it is clear to all of you. Okay. So now let us say if you have to draw the equivalent circuit. Okay. So as these circuit admittance parameters are measured with either input or output port short circuited, these are called the short circuit admittance parameter. So in why it is known as the admittance parameter? Because in every case we have seen that either you are going to short the input port or you are going to short the output port. So that's why, and you are measuring basically I by V ratio. So that I by V ratio means it is basically the admittance. Now this admittance is calculated when either you are shorting the input port or you are shorting the output port. And that's why it is known as the short circuit admittance parameter. Now the equivalent circuit of the two-port network in terms of the Y parameters. So you see we have written the equation I1 equal to Y11 into V1. So this is basically Y11. So this is known as, this is basically your Y11. So I will draw this thing in board so that you can understand. So we are going to basically draw the equivalent circuit of the Y parameter, okay, for two-port network. So we know that the basic equation, it is I1 equal to Y11 V1 plus Y12 V2 and I2 equal to Y21 V1 plus Y22 into V2. So if we draw the network, equivalent network, so this will be, this is an admittance. This is basically your admittance. And this is your basically dependent current source. Do you know the dependent current source? You have idea of the dependent current source? Yes or no? Please tell me. I cannot understand if you are not responding. Do you know dependent source?
No, sir.
Okay. So dependent source. Okay. I will try to make you understand this thing. Okay. Just a minute. Okay, just a minute. So let me draw this circuit first. So this is your Y11 and this is your Y12 V2. Now here you have another dependent source. This is your V2. This is your I2. Because in two-port network, V1 is the input voltage, I1 is the input current, V2 is your output voltage, and I2 is your output current. Okay, so that is basically general nomenclature. Now this is your Y22, and this is your another dependent source, that is Y22, Y21 into V1. Now you see, this is why this is called this particular thing, it is known as, here it is written Y12 V2. So this is basically a current source. When this kind of symbol will be there, this kind of symbol will be there. So this is basically your current source. This is your current source. Now, when we are writing in this type of decision box, then it is basically dependent source. This is known as dependent source. Now here you see this dependent source. This is a voltage dependent current source. Why? Here you see the magnitude of this current source. The magnitude of this current source, it is dependent on this particular voltage V2. Okay. So why it is this this is voltage dependent current source? Because the magnitude of this particular current source, it is dependent on V2. So basically this is a current source. This is basically a current source, but the magnitude of this current source, it is dependent on this output voltage V2. So, and it is multiplied with a scalar parameter, that is Y12. That is basically your admittance parameter. Similarly, so what is the, how we are basically drawing this particular circuit? You see, this I1 equal to Y11 into V1. So Y11 admittance into voltage. What is that? Admittance into voltage is equal to what? Please tell me. Admittance into voltage means what? Can you tell me what is admittance into voltage? Who can tell? Admittance into voltage means what? Correct. But Rohini Kumar, you have problem of your speaker? Cannot tell? Rohini Kumar. Okay, so I think you are not connected. Fine. Okay, but you need to check your speaker. Okay, fine. This is current. Okay, it is true that is current. So now you see, so this is your input current I1. So this current is divided into two parts. Okay, that is one part is this part, that is Y11 into V1 plus Y12 into V2. Who has drawn this particular line? Who has drawn? Please tell me. Who has drawn this line? Anyway, you erase it. Please erase it. If you have drawn it, then please erase. Hello? Who has drawn this line? Hello? First of all, all of you, please, switch on your video first. Switch on your video. All of you switch on your video. Okay. Yes, I can see at least.
Am I visible, sir?
Yeah, correct. Okay, very good. Rajnabi, I think Ranjana Ravi, are you there? Rohini Kumar, Rohini Kumar, Rohini Kumar. Are you there in the meeting? Sarita? Sarita,
Yes, sir.
switch on your video. Whether you are attending your classes, we cannot understand. No? Deepika? Deepika, are you there in the meeting? Deepika? Deepika, are you there? Should I remove? There in the class? I think you are not there. So I will remove now. Okay, fine. I think you are not attending this class. Fine. Now, Anushka Kumari. Anushka,
Yes, sir. Yes, sir.
You are there in class?
Yes, sir.
Switch on your video. Switch on your video. Yes, you are instructed that
Yes, sir.
you show me your copy. Your copy.
Yes, sir.
Just show in front of your camera that whatever you have written. Smile, smile, smile. Okay, okay, fine. Okay. So now let us say 3 people are in waiting. Okay, fine. Okay. So now you tell me. Okay. Okay, now you can switch off your camera. Okay. So one thing is this dependent current source. So this admittance into voltage, it is the current. So this source current. So this source current, this is I1. Now it has been distributed. It is distributed into 2 parts. One is your now one thing I request all of you, please you enter into this class at the time, because now if you are entering, so I need to do this. I have to admit. Okay, so it is disturbing. So now you see, so this admittance into voltage, this is correct. So that's why this is this parameter. Okay, it means this particular portion. Now y22 into y12 into v2. Now y12 into v2 is this current. Okay, so that means the source current I1 equal to y11 into v1 plus y12 into v2. Similarly, in your output side, this I2 equal to y22 into v2. So this is y22 into v2 plus y21 into v1. So this is your y21 into v1. Now this y21 into v1, this is also a dependent current source, but the magnitude of this current source, it is dependent on the input voltage. So that's why it is a dependent current source, or it is also known as the voltage dependent current source. Okay, so now I think it is clear. If you have any doubt, you can raise your doubt. So you can raise your doubt at any point of time. If you are facing any difficulty, please tell me. Okay. So next is our ABCD parameter. So we'll start a new parameter. So that is ABCD parameter, or it is known as the transmission parameter. Now in electrical and electronics, in electrical engineering, the student will actually handle with the transmission line parameters. But in EC department, you are going to handle this communication line parameter. So both the case, we have this ABCD parameter in due course of time. But now you will understand what is this ABCD parameter. Now, in this case, basically, the input voltage and input current, it is expressed in terms of output voltage and output current. So the transmission parameter, or it is also known as the chain parameter or ABCD parameter, serve to relate the voltage and current at the input port to the voltage and current at the output port. So basically, in this case, the input voltage and input current is expressed in terms of output voltage and output current. So this is the basically way we are going to express this transmission parameter. So how this network parameter is related? So V1 equal to AV2 minus BI2 and I1 equal to CV2 minus DI2. So now you see why this minus is introduced. Now you have a question. Okay, so I will go to the board and we'll discuss this thing. So now you see, in case of this ABCD parameter, the network equation, it is V1 equal to AV2 minus BI2 and I1 equal to CV2 minus DI2. Now what is this? Let us say in any two-port network, this is your V1 and this is your I1. Now, this is your V2 and this is your I2. So this is the common notation for any two-port network. Now, in case of transmission line, if you see any transmission line, it is basically unidirectional, because from the generator, so the generator is located generator, the generating station, it is far away from the load center. Okay, so this is the, let us say, generator. Now, after that, you have the transmission line. After that, you have a transmission line, and at the end, you have the load. Okay. So similarly, in terms of electronics engineering, we have basically you have a source station, and from there you are having a transmission line, and at the end you have a receiver. So basically a transmitter will be there, and then transmission line, and then you have a receiver, something like that. Okay. So the signal or basically the current in this case, it is basically going in the forward direction. Okay. So that means for the generator, if you consider that is the input port, so input port direction, current direction is this way. But the load side, the current is in the outward direction. But as per the convention of the two-port network, this current is in the inside. Okay, that means towards this black box. Okay, so this is your two-port network. This is your black box of the two-port network. But here you see, actually in the transmission line, the current is going in the outside direction. So actually the current is flowing in this direction, but as per convention, it is going in the inside direction. So what has to be done? This I2 will be taken as minus I2. So basically, this is the actual equation is AV2 plus B into minus I2, and then it is CV2 plus D into minus I2. This minus I2 is coming because of this particular explanation. Now, here also we need to calculate this parameter. So what has to be done? Either, let us say, we make I2 equal to 0. So if you make this I2 equal to 0, we can calculate A and C value. So A will be equal to V1 by V2, and C will be equal to I1 by V2. Now, what is this A? A is the ratio of two voltage. So ratio of the input voltage and to the output voltage, whereas C is equal to your I1 by V2. So I1 by V2, it is basically, this is basically voltage ratio, or it is also known as the voltage gain. Now here it is I1 by V2. This is I by V means it is basically your admittance. So I1 by V2, that is you are giving input voltage on the output side and measuring your current or the response you are measuring in the input side. So that's why it is from 2 to 1. So it is your reverse transfer admittance. Okay. Now all these things, it is happen when I2 equal to 0. I2 equal to 0 means your output port, this output port is open circuited. There is no current. So output port is open circuited. Now let us say this I2 is equal to 0, it is over. Now we'll take V2 equal to 0. So V2 equal to 0 means here output port is short circuited. Output port is short circuited. So how to calculate this thing? So we are going to calculate this B. B will be equal to V1 by minus I2, and D will be equal to I1 by minus I2. So that means V1 by minus I2, this is basically ratio of voltage by current. Voltage by current means this is basically impedance. Okay. So now here you see this D equal to I1 by minus I2. This is the ratio of the two currents. So that means now we'll go to the particular parameter. So here this negative sign is used with I2 and not for the parameters B and D. The reason for the current I2 carries the negative sign is that, so just now I have explained this thing. In the transmission field, the output current is assumed to be coming out of the output port instead of going into the port. So in matrix form, we can write V1, I1, ABCD, V2, minus I2. Now this ABCD is called basically the transmission matrix. So how to calculate this? So just now I have explained. So when the output port is open circuited, I2 equal to 0, A equal to V1 by V2, where I2 equal to 0. So this A is known as the reverse voltage gain with the output port open circuited. Now I2 equal to 0 means the output side is open circuited. Now it is basically you are taking the ratio of the two voltages, but you are going from 2 to 1. That's why it is known as the reverse voltage gain. Similarly, C equal to I1 by V2 with I2 equal to 0. Now here you are taking I by V ratio. So C is the transfer admittance with the output port open circuit, because I2 equal to 0 means output port is open circuit. Now when the output case 2, when the output port is short circuited, that is V2 equal to 0. So B will be equal to minus V1 by I2. So V2 equal to 0. So B is the transfer impedance with the output port short circuited. Similarly, D equal to I1 by I2, that is V2 equal to 0, where D is the reverse current gain with the output port open circuited. So V2 equal to 0 means your output port is short circuited, but you are taking the ratio of the two currents. So that is basically it is known as the reverse current gain. So any doubt up to this point? Any doubt? Anyone? You have any doubt?
No, sir.
Okay.
No, sir.
Fine. So now we are having only 7 minutes time because of this Zoom. Okay. So now just I will take your attendance, just a minute, and then remaining time we'll cover this thing. Okay. Now we'll discuss basically this H parameter, or it is known as the hybrid parameter. So the hybrid parameter of a two-port network may be defined by expressing the output voltage of input port, the voltages of the input port V1 and the current of the output port. So that means V1 and I2, it is expressed in terms of I1 and minus V2. Means that is the basically case in this hybrid parameter. Okay. So what is how we can express this thing? So V1 equal to H11 I1 plus H12 into V2, and I2 equal to H21 I1 plus H22 into V2. So basically V1 and I2, it is expressed in terms of I1 and V2. So similar way, V1 and I2, it is expressed in terms of I1 and V2. So how we can calculate this thing? So V1 and I2, it is expressed, it is in short form, H11, H12, H21, H22, and this is expressed in terms of I1 and V2. This way you can remember actually. So V1 equal to H11 into I1 plus H12 into V2, and I2 equal to H21 into I1 plus H22 into V2. So how to calculate this parameter? So first we'll make V2 equal to 0. So that means this side will be out, only we can calculate. So V2 equal to 0 means your output port is short circuited. Output port is short circuited. So your H11 equal to V1 by I1, and H21, this is equal to I2 by I1. Similarly, if you make this I1 equal to 0, so I1 equal to 0 means input port is open circuited. This is open circuited. So I1 equal, so in this case, we can calculate this H12 and H22. So H12, this will be equal to V1 by V2, and H22 will be equal to I2 by V2. Okay. Any doubt on this?
No, sir.
Okay. So are you getting my all this recorded video in the YouTube? Because in the departmental channel?
No, sir.
So you contact with
sir.
your electrical department, there is a YouTube channel, you contact with your HOD. Okay, there you will get all this recorded video. Okay, after this class also, these videos, all these video, it is uploaded in the departmental channel. So later on also you can refer these lecture notes. Okay, please contact with your HOD so that you can get this video. Okay, it is already there. You just get the link. Okay, you ask your HOD and you will get it definitely. Okay.
And sir, we are also not added in the classroom group.
Classroom group is
Yeah.
what? Which group?
Sir, sir, classroom where sir and ma'am send notes.
Okay, so where it is there, where it is actually, which classroom is Google Classroom?
Yes, sir, Google Classroom.
Google Classroom. For getting this lecture notes, yes, I will give you for my lecture. Okay, just wait for some time. I will cover this thing and I will post it. Okay, but none of the class you are getting. Do you mean that thing, or for my class only?
Sir, none of the class.
None of the.
None of the classes, sir.
I'll make some.
And sir, teachers. And sir, teachers said that they will talk to the principal, and then after they will join us, because sir, all the notes sent in the previous section, but sir said that you will join after some time.
We'll understand. We'll make some arrangement for you. Okay, definitely. I will do.
Yes, sir.
Okay, okay, fine. So for this, when the output port is short circuit, that is V2 equal to 0, H11 equal to V1 by I1, where V2 equal to 0. So where this H11 is a short circuit input admittance. Now H21 equal to I2 by I1. So that is V2 equal to 0, where H21 is the short circuit forward current gain. So here you see it is basically ratio between two currents. Okay, I2 by I1. Now we are going from 1 to 2. That's why it is forward current gain. Now when the input port is open circuited, I1 equal to 0. So H12 equal to V1 by V2, where I1 equal to 0. So H12 is the open circuit reverse voltage gain, and H22 equal to I2 by V2, where I1 equal to 0. So this H22 is the open circuit output admittance. So the same way, whatever way we have just now discussed, so the same way we can actually discuss, means we can understand the same thing. Okay. Now here you see that V1 equal to H11 into I1 plus H12 into V2. So this is a basically voltage source. So this voltage source, this is here, you see, previously it was a current source. Now here it is a dependent voltage source. Now the magnitude of this voltage source, it is dependent on the output voltage V2. Similarly, here you see V2 equal to, just we have to match with the equation, whatever the H parameter equation that we have to match. So V2 equal to your H22 into I2 plus, sorry, this I2 equal to the current I2 equal to H22 into V2 plus H21 into I1. Now this is a dependent current source. So dependent current source means this current is dependent on the input current. So we are actually, now we have exhausted our time. So next class, I will discuss the interrelationship between the parameters. So do you have any question? Do you have any question up to this H parameter? So you can refer any textbook of circuit theory where you will get all these things. Okay, but otherwise these recorded videos will be uploaded after this class. So you can refer those actually videos. So you simply write in the YouTube channel, that is electrical engineering. Okay, CEC electrical engineering something. So there you will get all these recorded video, because teachers are there uploading this video in this particular channel. I think this electrical engineering department, for other department also they are having all these different YouTube channels. But I will make some arrangements so that